Hello, welcome to Econometrics melody. So this is the user Stata interface. In order to activate your data editor, press Ctrl 8, and in order to activate your do file, press Ctrl 9. With the main Stata interface active each time. Let's begin. In this tutorial, we'll deal with programming functions in Stata. So let us clear everything and generate a variable using this random uniform distribution, and let's see how does the autocode work, right? So based on the values of variable a, we want to group it into 4 groups, and the groups should take the equal interval from 20 to 100. 20 to 100, so the space is 80 is the interval, so 80 divided into 4 parts, it's 20. 20 plus 20 is 40. So how did we generate the first group? And you see, if we table it, you'll see the difference. The difference between 20 and 100 is 80. Divide 80 into 4 parts, so we have an interval of, let's say 20, right? 20 is the interval. So first interval is 40, 60, 80 and 100. And let's see how does this C work. C is for constant, or it is for system constant, right? If you write current time, and this will display the current time. If you write current date, this will display the current date. And operating system that you are using, machine type, it's yes 64-bit. And what is my username? Let's see how does this clip work. 40 to 80, anything below 40 and anything above 80, they are marked 40 and 80 respectively, and in between, whatever numbers are in between, they are the same numbers are taken. Let us table it and we'll see the difference. We will get to see the frequencies and the higher frequencies for the extreme values 40 and 80 and the rest others. This is as if the if function in our Excel. So we provide a condition. If it's true, then we put it 1, and if it's false, this is 0. Okay, and if you table this, you see this is the condition. So if this condition is true, we write the value, we take a value 0, and if it's false, we take a value 1, and if it's missing, let's solve the case of missing, right? Let us replace the original variable by some missing numbers, and we say if it's missing, then we replace it by 99, 999 and another condition. So this is the combinations of the conditions. This is very simple, and you see what are the basic values table. So what does E name? E for estimate, R for result. Let us regress ABC, and then E return. It means return the estimates. What are the estimates list? So these are the estimates, and let's see what are the name of the estimates over here, so we can refer this, right? E for estimate. And now let us see what is the total number of observations. 3, because we have missing numbers and regression does not consider the missing values, right? What is the value of R? Yes, residual sum of squares is 75.4, mean sum of squares is 99.14, and R square it's 92. E sample should be 23 because it's the number of non-missing values that we have taken exactly in the sample. So E sample is true for the observations that is included in the sample, right? So all the missing values, or the missing values, they are 0. They are not a part of a sample. So if you table B, what happens? And you write a row as well, okay? See what happens, 0 and 1. So 7 observations are missing. Then after EPS double, machine precision for double. So this is the if you format. So what is the machine precision for float? This is the number. So what does the float do? This float will, you notice the changes. If you run the float command, then it will, let us format this and let us compare. So what is the difference between these two numbers? So it will round off. I don't know what is the exact difference, but you see after this 242 over here, and it's 222 from here it starts. This is the difference. Maybe the round off thing is going over there. So format width, so this will extract the length width for certain format, right? So for t, this leap second adjusted date and time, so the format is 18. For leap second on adjusted date and time, the format is again 18. The length of the format is 18. And this for days it's 9, for week it's 7, for month it's 7 as well, for quarter it's 6, and for half yearly it's again 6, and for yearly it's 4, and for 30 years we have specified the length as well, and for 19.7 it's 19. In range it's like true or false, and what does it do, whether the observations are between 20 or 50 or not. So true and false thing, this observation is not between 20 and 50, this observation is again not between 20 and 40. Let's write, if you write table B and then euro, you will know this. So let us drop everything and generate this observation, and let us run this command irecode. So what does this do? So we are going to create a categorical variable, and 0 to 10, 10 to 20, 21 to 40, and 41 to 80, and greater than 80. So 80, anything above than 80. So this will generate these variables, and if you sort AC, so above 80, this is 4. So if you table 0, and you'll get the result. So 0, 1, 2, 3, 4. I for indicator, or you can say it creates a code on its own. Let us see, others are very self-explanatory. Maximum byte, maximum number that byte can hold is 100, and minimum it's -127. Maximum integer value is this, minimum integer value is this, and let us drop base here, and maximum long, so this is the number, and let us format it if we can really. So this number is maximum number, and what is the minimum number for long? 10 didn't work. If we write 12, what will happen to this? Is it a fixed one? Okay, this didn't happen. Okay, it does not matter, no worry guys. Write the maximum float, minimum float, what are the numbers? So this is the maximum for the number, and what is the minimum float? This is the minimum for the float. And maxdouble, I didn't get any result for maxdouble, and mindouble. Okay, I don't know what is the error, don't mind it. So am I for missing? Don't worry, we have seen this. B, if it's missing, so if it's missing we get true, and if it's not missing, false. This is also very useful. And mi are missing, they provide the same results. So let us drop BC, and we can use this missing. Then B equals to missing 1, 2, 3, 4, 5, 6. So in this observation, if there is anything missing, we'll get true. So the entire observation is true, and if there is nothing missing in this observation, then we get false. Okay, so these are the observation actually. So it's false, everything is false. R name, R is for result, and let us see what does it do. So let us summarize, create some results, a return list. We see these are the results. So if we have R is a prefix, so this function R, this stands for result, E stands for estimation or estimate, and we get the values. So if you reference this R and En, you'll get this value. R sum W, you get this, variance this. So let us see some of the values. So what is the mean? Here see, mean is 39.107. So this should be V, and let us do this once again. Let us drop basic, summarize, and let us return the list. You see, for estimate, we used to write E return. For R, we simply write a return. So let's see, let's write the value of mean. It's 39, and variance is this 663.508. Replace R sum, so sum is 1095, and this is how we can standardize our value, right? Any variable, subtract, deduct its mean and divide by its standard deviation. This is the standard form. Okay, now recode is also another very interesting autocode. So how does it work? It creates 0 to 15 as one category, 16 to 50 as another category, you see. So anything between 0 to 15 is 15, anything between 16 to 50 is 50, anything between 51 to 65 is 65, and anything greater than 65 is 80. Anything less than 18 is 18. Anything greater than 19 to 44 is 44. Anything greater than 45 is 67. So anything greater than 45 is 67. Have we sorted this data? Yeah. So anything greater than, you see, 45 is 67. These are some of the programming functions in Stata. Thank you very much for your time. Thank you very much. Econometrics Melody.